Hello. Today we are going to be talking about two variable equations. We'll start by looking at a very simple one, x plus y equals 5. Again, obviously there are two variables here. We want to list some answers, so I think it's pretty clear some of the answers like 1 plus 4, 2 plus 3, I missed a 0 plus 5, 3 plus 2, and 4 plus 1, and 5 plus 0. So again, those are the obvious ones, the positive numbers. All right, now we could also get a little tricky and get negatives involved, like -1 and 6, and -2 and 7, and -3 and 8. And yes, you're seeing a pattern for a reason here. So again, there's definitely negative numbers that work, and I could have also flipped those, which would be different answers. All right, 6 plus -1 is a different problem than -1 plus 6. So again, we could do that. We've also could get tricky and start doing fractions and decimals. Things like 4 and 1/2 plus 1/2, or 3.7 and 1.3. Okay, well, the key is, in the end, that's doing too much. I don't want to list all those stinking answers every single time. That's too many answers. Plus, they never end. It's an infinite number of answers I could find. All right, so turns out if I were to graph those, like the first one we listed, 0, 5, would be up here somewhere, and then 1, 4, and then 2, 3, and then 3, 2, and then 4, 1, and then 5, 0, and then -1, 6 would be up here, and 6, -1 would be down here, and the fractions like 4.5, 1/2. Turns out they all line up straight. So these are called linear equations. If you graph their answers, they make a straight line on graph paper. All right, again, that just means there's lots of patterns involved. All right, so let's take a look at an example of what work we're going to do today. All right, we're going to be graphing an equation using a table so that we don't have to find every single answer. We're just going to find a few answers, but the problem's a little uglier than the one we just looked at. So the answers aren't going to be quite so obvious. All right, we can't just look at that and go, oh, 4 and 2. It's not as easy as that. We're going to have to do a little more work. All right, so first step in that work is to pick some numbers that we can plug into the problem and find their partner. Every number will work. Again, there's infinite answers to this, so every number will work if you find a right match partner with it. So we want to find a matching partner. So we're going to pick one of the numbers, like right here, x equals -4. And we're going to plug that number into the equation where the x is, and we're going to figure out what number would go with it. So 1/2 times -4 is -2, plus 3 makes 1. Now I can go ahead and graph that on graph paper, because that's acting like an ordered pair. So -4 and 1 would be right here on my graph. All right, now I'm going to do another one. Now I'm going to plug in a -2 into the same equation in the same spot. Now obviously this is something you can do on a calculator. You don't have to show your work on this. But 1/2 of -2 is -1, then plus 3 makes 2. There's my next dot at -2 and 2. Then I'll do it again, plugging in a 0. And again, at a certain point, you become a little better at these, and you start doing less of the show your work stuff. And again, with us being home half the time this year, I am fine with a lot less of the show your work stuff. All right, the next one, you plug a 2 in. So again, if you don't want to write the whole thing out, and you just want to do, well, 1/2 of 2 instead of 0, 1/2 of 2 is 1, and then plus 3 makes 4. There should be a dot at 2, 4. And the next one, 1/2 of 4 is 2, plus 3 makes 5. There's another dot. And we could keep going. That's a terrible location. I missed. And again, now we can draw the line. Another thing I'm hoping that you saw on this was that there are some patterns going on. For example, this X column pattern, if you noticed it, it was a +2 pattern. All right, that +2 pattern is, again, in the X column. Think about X-axis. X-axis goes left and right. For doing rise over run, the left and right motion is the run, and there's that same +2 pattern we see. On the right-hand side, when we've got the Y-axis, we're having a +1 pattern down that side. The Y-axis is up and down, commonly referred to as the run, and there's that number. So like I said, there's patterns everywhere with linear equations. All right. Now, the only thing that we haven't talked about yet is what if there is no information already filled in the table, and you have to pick your own numbers. All right. Well, first off, pick the numbers that are easier to plug into. If you look at that equation, something special about it, and what's special about it is that the y is already by itself and solved. So that's the easier number to find. So that means we want to pick numbers for x. We want to pick numbers that are easy to do math with. Things like zeros, ones, twos. Zero is always a great number to choose. But if I pick 1, let's look at this equation. If I pick 1, that's 1/3 times 1 plus 4. 1/3 times 1 is 1/3, and the answer would be 4 1/3. And I don't want to graph that. I would much rather be graphing with whole numbers. So sometimes the numbers you pick do matter. So in this one, what we're going to do is, I'm going to put the 0 there. I'm going to put the 0 here. I'm going to pick numbers that will easily work out with the 1/3. So numbers that are multiples of 3. Like -3, +3, and +6. I could have picked 9, but 9 wouldn't fit on the graph, so that's why I went back to the -3. And then you plug those numbers in, and this won't happen with the whole fractions. That's, again, you can do it that way. That wouldn't have been wrong. It's just way easier to plug in a -3 here, because now 1/3 of -3 is just -1. And then +4 is 3, no fractions. All right, this is what your work looks like today. Good luck.